These are notes from Mel Ham's Math 60 at City College of San Francisco for Monday, April the 13th, section 8.1, page 688. Section 8.1, we deal with something called the square root property, which says if you have x squared equal to some number k, then x is equal to plus or minus the square root of k. This plus or minus is exactly that. It's either the positive or the negative, so we say plus or minus. As a simple example, x squared equals 9, then x is plus or minus the square root of 9, or plus or minus 3. Quick word that I'll mention, sometimes people mistakenly go straight from here to saying x squared equals 9. Oh, I would just take the square root of 9, which is 3. And you do have the 3, but you leave out the negative 3. Negative 3 also works because negative 3 squared is equal to 9. So what you have to remember when you're doing the square root property is while in the process of taking the square root, there always has to be a plus or minus here. So problem number 19, x squared minus 50 equals 0. So we move the 50 to the other side, so I'll add 50 to both sides. X squared equals 50, and now this looks like that. So I do the square root property. X is equal to plus or minus the square root of 50. And you might recall from a previous section that 50 I can write as 25 times 2, and then take out the square root of 25 as 5. So the best final answer is plus or minus 5 radical 2. Okay, this is a shortcut for saying negative 5 radical 2 and positive 5 radical 2, but we can make it more compact by just saying plus or minus 5 radical 2. For 29, 6b squared plus 144 equals 0. You want to isolate the b squared, so first I'll subtract 144 from both sides. 6b squared equals negative 144. Divide both sides by 6. b squared equals negative 24. So that looks like we're going to have an imaginary solution. So by the square root property, b is plus or minus the square root of negative 24. So you might recall when you have the square root of a negative, the negative will come outside and become an I. So I have plus or minus I radical 24, but 24 I can write as 4 times 6. And 4 being a perfect square, we'll change that to a 2 the next step. So we'll have plus or minus 2I radical 6. 31, the quantity x plus 5 squared is equal to 9. So do the square root property. Take off the 2 here. X plus 5 is plus or minus the square root of 9, which is plus or minus 3. And then I subtract 5 on both sides. So x is negative 5 plus or minus 3. Now when you get a solution that looks like this, then you should actually work them both out. Negative 5 minus 3 is negative 8, and negative 5 plus 3 is a negative 2. Back up here, 37, they make the problem just slightly more complicated. They say as a function, g of a is 7a minus 2 squared, and they want you to find the value for which g of a is equal to 8. So I simply just replace g of a with 8, so set 8 equal to 7a minus 2 squared. So now that kind of looks like this problem, except this thing was on the left side, they put it on the right side, but it's basically the same thing. So by square root property, 7a minus 2 is plus or minus the square root of 8. Add 2 to both sides, so if 2 plus or minus the square root of 8, but 8 you can write as 4 times 2. And we know that on the next step, the square root of 4 is going to become a 2. And while I'm at it, I'll divide 7 on both sides. So we have a is 2 plus or minus 2 radical 2 all over 7. And you may leave your answer just like that. The next set of problems involves something called completing a square. For completing a square, there's a process. You have to remember that you're doing something called half and square, and I'll show you exactly what that means. Essentially, you take half the coefficient of x and then you square it. So here's an example. We have some warm-up exercises. 39 and 43 are not full-fledged equations like 47 and on. They're just warm-ups. They're asking you what number do you add so that you end up with a perfect square. So x squared plus 24x, let's apply this half and square principle. So I take half the coefficient of x, half of 24 is 12, that's the half part, and then I'm supposed to square, so 12 squared is equal to 144. So the thing I'm going to add in this example is that 144. So going back to the original, x squared plus 24x, and then I add in red here 144, because that makes this expression a perfect square now, and that perfect square is x plus 12 squared. Normally when you get to this stage, all you need to do is give me the square root of this, square root of x squared is x, and the square root of 144 is 12. And so this factors in x plus 12 squared. Another example is 43, except they have a fraction, but we do the same thing, x squared plus 2/3 x. They want me to add something and then end up with a perfect square. So I apply this half and square principle. I want half the coefficient of x, so half of 2/3. 2 cancels out, so I have 1/3. And now I square the 1/3. 1/3 squared, 1/3 times 1/3 is 1/9. So from the original expression, I'm going to add 1/9 in red, x squared plus 2/3 x plus 1/9, and now factor it into the square root of this, which is just x. The square root of 1/9 is 1/3. I keep this sign, so it's x plus 1/3 squared. In other words, if you were to multiply this back out, x plus 1/3 squared, you end up with this expression. And then starting with 47, we're solving equations now with something called completing the square. So I apply this principle to solving an equation, which incidentally, a lot of these cannot be factored. So even though factoring might be easier, well, sometimes you get a polynomial which doesn't factor, a quadratic which doesn't factor, then you have to do completing the square, or the quadratic formula, which we'll talk about next time. So look at 47, x squared minus 4x minus 2 equals 0. First thing I want to do is move the constant over to the other side, so I'll add 2 to both sides. X squared minus 4x equals 2. Now I do the completing the square process, half and square. So I take half the coefficient of x and square it. So half of negative 4 is negative 2. Square that, negative 2 squared is equal to 4. So I'm going to add 4 to both sides of the equal sign. Remember, whatever you do on one side of the equal sign, you do the other side. So x squared minus 4x equals 2. In red, I add 4 to both sides. So 2 plus 4 is 6. And by adding 4 on the left-hand side, x squared minus 4x plus 4, that turns this into a perfect square. And the fast way to factor that is to just give me the square root of x squared, which is x. The square root of 4 is 2, and keep this sign. This sign is a minus, so I put a minus here. If this was a plus, I put a plus. So I have x minus 2 squared is equal to 6. And now the rest of the problem I can solve with the square root property. So by the square root property, x minus 2 is plus or minus the square root of 6. Add 2 to both sides, and x equals 2 plus or minus radical 6. Now in the homework it says to give a decimal approximation. I'm going to forego that, so we won't worry about decimal approximations. That's just punching in a calculator. This is not a calculator class, so I don't think it's necessary to worry about the decimal approximation. You can plug it in if you want, but we'll just stop when we get to this, 2 plus or minus radical 6. Okay, problem 53. T squared plus 16t minus 16 equals 0. So move the constant over by adding 16 to both sides. So t squared plus 16t equals 16. Now I do the completing the square. So I take half the coefficient of t and square it. So half of 16 is 8. Square that, 8 squared is equal to 64. So 64 is the thing that I'm going to add to both sides of the equal sign. So I add 64 here, add 64 here. You can see that I have that in red. So the right-hand side becomes 16 plus 64, which is 80. On this side, I have t plus 8 quantity squared. Again, the best way to factor is to just give me the square root of that, which is t. Square root of 64 is 8. And again, if you can double check, you can multiply t plus 8 squared. You'll see that you get this back. Now I'll just do the square root property. So taking the square root with a plus or minus, t plus 8 equals plus or minus the square root of 80. Subtract 8 on both sides, so I have negative 8 plus or minus the square root of 80. 80 is equal to 16 times 5. I want 16 because it's a perfect square. That's going to become a 4. So t is equal to negative 8 plus or minus 4 radical 5. 55 and 59, a little bit different. Up to now, all our quadratics have had a leading coefficient of 1. It was just x squared, t squared. There wasn't 2x squared or 3x squared or whatever. So what happens if they give me a 2x squared? Well, before I begin, I'll just simply divide by 2. That forces that leading coefficient to be a 1. Over here, they start off with a 3x squared. I would just simply divide by 3. So whatever they give you here in terms of a coefficient, let's say it's 7x squared plus blah, 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 I would just divide by 7. So in this case, 2x squared minus x minus 1 equals 0 is the original. And then in red, I just divide both sides by 2. So I always want to begin with an x squared. So this gives me x squared minus a half. You can pretend there's a 1 here. Minus a half x minus a half equals 0 divided by 2, which is 0. And now it's good to go. Add 1/2 to both sides. So x squared minus a half x equals a half. Now I complete the square. I do the half and square business. So half the coefficient of x. Half of negative a half is negative 1/4. Square both sides. Negative 1/4 squared is 1/16. So in red, I add 1/16 to both sides. So plus 1/16 plus 1/16. On the right hand side, I have 1/2 plus 1/16. The common denominator would be 18, so that's why I put here in green multiplied by 8 over 8, so that this would become a 16, and that's also a 16. Now I factor that. Now you might not be comfortable factoring fractions, but again, all you need to do is give me the square root of this, x, and the square root of 1 over 16 is 1/4, and keep that sign. So x minus 1/4 quantity squared. This is 8 over 16 plus 1 over 16 is 9 over 16. Then I do the square root property. Square root x minus 1/4 equals plus or minus the square root of 9/16 is 3/4 very conveniently. Add 1/4 to both sides, so I have x is equal to 1/4 plus or minus 3/4. And again, when you get rational solutions like this, work them both out. So I do 1/4 minus 3/4, that's a negative 2/4, which is the same as negative 1/2 reduced. And then I have 1/4 plus 3/4 is 4 over 4, which is the same thing as 1. So we reduce our answers to negative 1/2 and 1. 59 is similar. They start off with 3x squared minus 12x plus 1 equals 0. I don't want the leading coefficient, the coefficient in the beginning, to be 3. I want it to be 1. So I just simply divide both sides by 3. So that gives me x squared minus 4x plus 1/3 equals 0. Subtract 1/3, so x squared minus 4x is equal to negative 1/3. And continue back up here. Now I do the complete the square business. I want half the coefficient of x. Half of negative 4 is negative 2. And then square that. Negative 2 squared is 4. So 4 in red is what I add to both sides. So x squared minus 4x back here plus 4 in red equals negative 1/3 plus 4, which is the same as 4 over 1. 3 is my common denominator, so in green I multiply this fraction by 3 over 3. This factors into x minus 2 squared is equal to negative 1 plus 12 is 11 over 3. And then I do the square root property. So square root of that is x minus 2 equals plus or minus the square root of 11 over 3. And I'll rationalize the denominator by multiplying this fraction by radical 3 over radical 3. And I'll add 2 to both sides. So 2 plus or minus radical 33 over 3. Common denominator is 3. So 2 is the same as 2 over 1. In green, I multiplied top and bottom by 3. So the best final answer is 6 plus or minus radical 33 all over 3. Finally, for 63, we're going to have complex solutions. There's a real part and an imaginary part. And p squared plus 2p plus 2 equals 0. Subtract 2 on both sides. The constant always moves over. P squared plus 2p equals negative 2. Complete the square. Half the coefficient of p, half of 2 is 1. Square that 1. 1 squared is still 1. So I add 1 to both sides. Notice the right-hand side will still be a negative. You get a negative 1, so I'm going to be taking the square root of a negative number, which means I'll have to have an I in my answer. This factors into p plus 1 squared. Again, the simple way to do it is just give me the square root of that and the square root of that. So keep that sign. P plus 1 squared is equal to negative 1. So by the square root property, p plus 1 equals plus or minus the square root of negative 1. Square root of negative 1 is defined to be I. And subtract 1 on both sides. So p is negative 1 plus or minus I will be my solution set for that problem. All right, so these are the notes for Melham's Math 60 for Monday, April the 13th, section 8.1, page 688.